All right. What is up, guys? Mr. Rushka here with another video. Okay. So I know we didn't do too hot on this quiz. Okay. And that's okay. Okay. I'll be honest with you guys. The way this class is graded, right? So if you look at the syllabus, it's 90% tests and quizzes and 10% homeworks. Okay. What's good for you guys? Okay. The reason it's not a huge deal that we didn't do great on the quiz. Okay. It's 15 points, okay? And all of the tests and quizzes are in one category, like one grading category, okay? The grading category is tests and quizzes, okay? All of the tests I give you are out of 100 points. We'll probably have at least 2 tests this quarter, if not 3, and then a bunch more quizzes. I mean, we're trying to do quizzes once a week, okay? So this 15-point quiz, given that there's going to be a bunch of other 15-point quizzes and a couple of tests that are worth 100 points each, means that we have plenty of time to recover from this quiz, okay? So I'm glad we had that shock, actually. I actually think it's a good thing in the long run, okay? Um, that being said, right, we do need to make sure we brush up on all the stuff that's going to be on the test that we didn't do well with on this quiz, okay? So that's why I'm making this video, okay? Cool. So just a couple things you need to know for the test, okay? You need to be able to draw these 4 triangles from memory, okay? Again, they're the same triangle, okay, right? 2, root 3, 1, 2, root 3, 1. The only difference is this triangle is in radians and this triangle is in degrees, okay? Same over here. This is a 45, 45, 90 triangle. This is a pi over 4, pi over 4, pi over 2 triangle, okay? All right. I'm going to show you guys how to do these 10 especially we struggled with. I'm going to show you how to do them. I think I'm going to try to streamline the method, make it a little better for you guys, okay? So just a couple things you do need to memorize, okay? Especially to do this first problem, okay? Couple things you do need to memorize, okay? So, ka, toa. So, ka, toa. Okay? What that means is, okay, the sine of an angle theta is equal to the opposite side of the triangle that it's in over the hypotenuse of that triangle, okay? All right, ka means that cosine of theta is equal to the adjacent side over the hypotenuse, okay? And toa means that the tangent of an angle is equal to the opposite side over the adjacent, okay? And that's geometry review, okay? So I'll draw a right triangle real quickly, okay? Just a little review. I'm trying to make this as detailed and thorough as possible. If we have an angle theta here, right? Okay, it's going to have a hypotenuse, okay? So this is the hypotenuse, h, and 2 legs, okay? This leg that's across from theta, the leg that's across from theta is called the opposite, and then the other one that's right next to theta is called adjacent, okay? So that's what these 3 ratios mean right here, okay? So you do need to know that, okay? SOHCAHTOA, that's going to be your friend. And then you need to know, right, especially for this problem, that cosecant of theta equals 1 over sine of theta. Secant theta equals 1 over cosine of theta. And tangent of theta equals 1 over cotangent of theta equals 1 over the tangent of theta, okay? So those are things you just need to know. You need to memorize them, okay? All right, we can do that, though. All right, so let's talk about number 1 real quick, okay? Find all 6 trig functions of this angle theta. This is an angle right here, okay? All right, here's how you do it, okay? So this point here is at negative 3 comma 5. What that means is if we draw a line down here to make a right triangle, okay? All right, so the x-coordinate of this point is negative 3. That means it's 3 to the left of the origin, okay? So 1, 2, 3. So this bottom side here has a length of 3, and then the y-coordinate is positive 5, so up 5. 1, 2, 3, 4, 5, okay? So this line here has a length of 5, okay? Let's not forget, okay? Sexy tiger cat, okay? So I'm going to label all of those quadrants with one of these letters, okay? In this quadrant here, the A means that all of the 6 trig functions are positive. Okay, so if an angle has a bearing that we draw in the first quadrant, all of its trig functions are positive. So sine of that angle is positive, cosine of that angle is positive, and the tangent of that angle is positive. And then all the reciprocal, the cosecant, secant, and cotangent would all be positive. Okay. If we have an angle whose bearing we draw in the second quadrant, this S here means that the sine of theta and only the sine of theta, well, I guess and the cosecant, so the sine of theta will be positive. Okay. The cosine and the tangent will be negative, okay? What that also means is since cosecant is 1 over sine, cosecant will also be positive here in the second quadrant, and then secant and cotangent will be negative, okay? If we draw an angle whose bearing is in the third quadrant, okay, the tangent and cotangent of that angle will be positive. Everything else will be negative. And then likewise in the fourth quadrant, if we draw an angle whose bearing is in the fourth quadrant, the cosine of that angle will be positive. The secant of that angle will be positive since secant is the reciprocal of cosine. And all the other trig functions will be negative, okay? All right, so here, right, we have an angle whose bearing we drew in the second quadrant, okay? So the sine and cosecant of that angle will be positive. The cosine, secant, tangent, cotangent will all be negative, okay? So let's find all 6 trig functions, okay? So here's, so what's going to happen then, this angle theta here, right, it'll have all the same trig function values as this angle right here. That blue, I'll do a different color, as this red angle right here, okay? The only difference is that if there's a trig function that's not sine or cosecant, we have to make it negative, okay? So let's start with sine, okay? So to figure out the sine, right, we need to know the hypotenuse length, okay? And to do that, we can just use the Pythagorean theorem, okay? So my 2 legs, 5 squared plus 3 squared, the sum of their squares here has to equal the hypotenuse squared, okay? That's 25 plus 9 equals hypotenuse squared, or 34 equals hypotenuse squared, okay? Let's take the square root of both sides, okay? You get hypotenuse equals the square root of 34. We only want the positive square root since lines can only have positive length, okay? So the sine of this angle is going to be 5, the opposite side, over the hypotenuse, okay? 5 over root 34, okay? Let's wait, and I'll rationalize all of these denominators at the end, okay? The cosine of this angle is going to be the length of the side adjacent to that angle over the hypotenuse of that triangle, okay? So it's going to be 3 over root 34. And again, we'll wait to rationalize till the very end, okay? The tangent, okay, is going to be the opposite over the adjacent side, okay? 5 over 3. This leg is opposite the angle. This leg is adjacent to the angle. So tangent's going to be 5 over 3. But let's not forget, guys, right? We're in the second quadrant, right? That's where sine and only sine is positive. So cosine and tangent both have to be negative, okay? And then to go from sine to cosine, to go from sine to cosecant of theta, we just flip that sine value over. Same for secant. We're just going to flip it right over. Okay. And then for cotangent, just flip it right over. Okay. Good. Now, the last step here is rationalizing these denominators. So I multiply the top and bottom by that square root that I have on the bottom. So 5 root 34 over 34. Okay. Oh, it blends in. Let me draw another negative sign. There we go. So those are my answers right there, okay? All right. We did fine with this one. Yeah, I'm not going to talk too much about this one. We did fine. Okay, it's somewhere around here. It's a little closer to 270 than to 180. All right, let's get to the real deal here. Let's get down to the real business, okay? Sine of 45 degrees, cosine of 330 degrees, okay? I'm going to go ahead. I'm going to highlight these three problems right here, okay? And I'll talk more about why I highlighted those in a bit. I'm going to start with sine of 45 degrees, okay? All right. So here's how we do these. I'm just going to go and ahead and review the entire thing, okay? I'm going to come down here, okay? I'm going to draw a line. I'm going to draw an angle. I'm going to draw a 45-degree angle because we're trying to find the sine of 45 degrees, okay? All right. I'm going to go ahead and talk about how we set up our axes here, okay? So I have an angle right here, right? I can make the angle bigger. I can make it smaller, okay? But I have an angle, okay? If I take this angle here and I keep raising it up, 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 all the way to 90 degrees, okay? I have a right angle there. That's a 90-degree angle, okay? Let me do that in black real quick. 90-degree angle, okay? So we call, if I'm drawing these as coordinate axes, okay? I have a 90-degree angle here, okay? If I were just to have an angle, right, and I just made it all the way down here, that'd be a 0-degree angle, right? There's not really an angle there, so it'd be a 0-degree angle, okay? That's the angle we have on the positive x-axis, okay? Let me draw another angle, okay? I'm going to draw it. I always measure my angles up from this red line here, from the positive x-axis. So I'm going to make a 180-degree angle now, okay? So I'm going to go all the way around, just flip it around, okay? That's, oh shoot, sorry. Oh gosh. Boom. It's a 180-degree angle, okay? So that's why I'm a perfectionist. I got to make it perfectly straight. There we go. So we call this angle 180 degrees right here, okay? And I'll go back to black, okay? If I want to make a 270-degree angle, oh gosh, right? If I want to make a 270-degree angle, I'm going to go 3/4 of the way around. So that'd be 90 degrees, 180 degrees, all the way down to 270 degrees, okay? So I just rotated around the origin 270 degrees, okay? And then again, if I were to draw a 360-degree angle, right, I'd go all the way around the circle counterclockwise, okay? And this would be a 360-degree angle. So the 0-degree angle and the 360-degree angle are the same, okay? And then we can also, and we really struggled with this, we can convert all these angle measurements to radians, okay? So this 0-degree angle here is also a 0 radian angle, okay? A 360-degree angle is also a 2 pi angle, okay? Because 0 times pi over 180 equals 0, and 360 times pi over 180 equals 2 pi, okay? So that's where that comes from. All right, so then 90 degrees is the same. If we multiply that pi over 180, we get pi over 2 radians. 180 degrees, if we multiply that by pi over 180, we get pi radians, okay? I'm going to call it 1 pi. That's going to help us, okay? I'm just going to say 1 pi instead of just pi. I'm going to say 1 pi. And then 270 degrees, if we multiply that by pi over 180, we get 3 pi over 2 radians, okay? Good stuff, okay? So this first problem here, it's a 45-degree angle. Doesn't matter as much for this first one, but here's how I'm going to try to teach it this time, okay? Here's a good way of thinking about it. And it's the same we've been doing, okay? So I'm going to draw, it's given in degrees, okay? I don't think we're struggling too much with degrees. I think we can all draw a 45-degree bearing here, okay? It's right there, okay? This angle right here is 45 degrees, okay? Here's how I want you guys to think about this, okay? This bearing that I just drew is on the same side. It's on the red side here. It's on the red side. Okay, it's on the right side of the origin. Okay, what I want you guys to do is if your angle's on the right side, okay, if it's on the red side, I want you to just subtract it from this angle here, that whatever angle is on the horizontal axis of the side that you're on. So the right side horizontal axis is 0 degrees. So I want you guys to do absolute value of 45 degrees minus 0 degrees. That gives you 45 degrees, okay? Once you have this number right here, stop what you're doing, go right up to your special right triangles, and find the sine of that angle you just highlighted, okay? So 45 degrees. We're going to find the sine of 45 degrees, okay? So I can use either of these. I'll just use the top one, okay? So the sine of 45 degrees, that's opposite over divided by the hypotenuse, okay? So the side opposite 45 degrees has length 1. The hypotenuse of this triangle has length root 2. So it's going to be 1 over root 2. Okay? And again, after we do that, just make sure you have the right sign, okay? So don't forget, sexy, tiger, cat. So since this angle's bearing was in the first quadrant, all of the trig functions are positive, so sine is positive. Good. So all I have to do now is rationalize my denominator, okay? So this is a positive, so root 2. My answer is positive root 2 over 2, okay? Good stuff. All right, cosine of 330 degrees. Cosine of 330 degrees. So let me erase some of this stuff right here. Cool. All right, so we're going to do cosine of 330 degrees, okay? I think we're doing pretty well with degrees, so I'm just going to draw this right on here, okay? So 330, right? It's greater than 0, so it's greater than 90, so it's not going to be in the first quadrant when I draw that bearing. All right, 330 is greater than 90, and it's greater than 180, so it's not going to be in the second quadrant. I got to keep going around the circle. It's greater than 180, and it's greater than 270, so I got to keep going around. I'm going to end up drawing it in the fourth quadrant here, okay? It doesn't really matter how well you draw the bearing. You just need to make sure you know what quadrant the bearing is in, okay? So it's going to be around here somewhere, okay? Again, this is 330 degrees, okay? So what I want you to do, okay, knowing that my bearing is on the same side as this red axis, it's on the same side as these red numbers here, okay? What I want you to do, I want you to take the angle they gave you, 330 degrees, and I just want you to do the absolute value of 330 degrees minus, you can do 330 degrees minus 360 degrees, okay? That's going to give you 30 degrees, okay? This is your reference angle. So we get the reference angle by literally just taking whatever angle they gave us in the problem and subtracting it from the numbers on the left or right side of your axes, depending. And if you're in one of the quadrants that's on the right, you subtract it from the numbers on the right side of the axes. If your bearing of your angle is somewhere on the left side here, you're going to subtract it from these numbers on the left side. And I said absolute value, okay? Because if you guys subtract them in the wrong order, all you have to do is take the absolute value, and you don't have to worry about subtracting them in the right order, okay? So once we have this is what we call our reference angle. Our answer is going to be the exact same. Our cosine of 330 degrees is going to be the exact same as the cosine of 30 degrees, except we just need to make sure we get the negative or positive right, okay? So 30 degrees, we're going to find, what does the problem want? The cosine of 330 degrees. So I'm going to go down here, find the cosine of 30 degrees with my special right triangles. Here's my 30-degree angle. The side adjacent that 30-degree angle has a length of root 3, and the hypotenuse of that 30-degree angle has a length of 2, okay? So adjacent divided by hypotenuse is going to be root 3 divided by 2. Okay? Let's make sure we get the SIGN of that angle correct. Okay? So my bearing here is in the fourth quadrant. In the fourth quadrant, cosine of an angle is positive. Okay? So this cosine here of 330 degrees needs to be positive. I'm done with that problem. Okay? Moving on. Cosecant pi over 3. Now we're in radians. This has been giving us a lot of trouble. Okay? This has been giving us a lot of trouble. All right? First off, I have to remember that the cosecant of an angle is equal to 1 over the sine of that angle. So cosecant of pi over 3 is going to be 1 over the sine of pi over 3. Okay? So let's start. I'm going to start by finding the sine of pi over 3. I'm going to find the sine of pi over 3 and then just flip it around, and that'll give me the right answer, okay? So let's think about this. Pi over 3 radians. Where would that bearing be? Where would the bearing of pi over 3 radians be, okay? Yeah, so let's think about this. The best way to draw this bearing is just to ignore the pi. So instead of pi over 3 radians, think of just 1/3, okay? Ignore the pi's on the angles on your axes, okay? So instead of thinking of pi over 2, think of it as just 1/2, okay? So 1/3, right? 1/3 is greater than 0, but 1/3 is also less than 1/2, okay? So your bearing for pi over 3 radians is going to be somewhere here. And I'll erase this, sorry. It's going to be somewhere in this first quadrant here, right? Anywhere in that first quadrant. I'm not even going to draw the triangles anymore, guys, okay? All I need to know is what quadrant that bearing's in, okay? Once I know that I need to take that angle and subtract it from these numbers right here, okay? I'm on the right side of the origin. I'm on this red right side of the origin of the coordinate axes. So I'm going to subtract this angle they gave me, pi over 3 radians, from the numbers here, okay? And I'm going to take the absolute value. So absolute value of pi over 3 minus 0. This one's easy, which is pi over 3, okay? So I'm going to find the sine of pi over 3 with my special right triangle. So come down to your special right triangles, look at your pi over 3 angle. We're going to find the sine of that, okay? SOHCAHTOA. Sine is opposite divided by hypotenuse, okay? So it's going to be root 3 divided by 2. So the sine of pi over 3 is the square root of 3 divided by 2. Let's make sure we got the positive or negative right, okay? So this bearing we just drew is in the first quadrant, the all quadrant. So the sine is going to be positive because all trig functions of angles whose bearings are in the first quadrant are positive, okay? So then to finish the problem, right, the answer up here then is going to be just taking this guy and flipping him over. So it'll be 2 over root 3, and then we need to rationalize. So it's 2 root 3 over 3, okay? All right, number 4. So this is a highlighted problem, okay? Here's why I highlighted this, okay? Let me get rid of this first, sorry. Okay, when they give you one of these 4 angles, if they give you an angle that's 0, pi over 2, pi, or 2 pi, okay, or let's do this in degrees, 0 degrees, 90 degrees, 180 degrees, 360 degrees. If they give you one of those 8 angles, this is going to be a gimme, okay? It's going to be a gimme. So if I draw this little circle right here, come on, oh my gosh. Let me do it in a different color. Okay, if I draw this circle here and I put points, this is a unit circle, so radius of 1. Okay, I'm going to draw in all these points. Okay, all you're going to do is you're just going to end up copying down. So like for this one, it's secant of pi over 2. I'm literally going to end up copying down one of these coordinates. So this is I look at the pi over 2 angle here, the pi over 2 axis, that positive y-axis that's labeled with the pi over 2 angle. And I'm just going to copy down one of these coordinates of this point here, okay? 0 or 1, okay? So the x-coordinate of one of these points is always going to be the cosine of that angle. The y is going to be the sine of that angle, okay? And then the tangent is going to be the y divided by the x. Or you can also think of it as the sine divided by the cosine, okay? So they gave me secant of pi over 2, okay? Remember that secant is 1 over cosine, okay? So I'm first going to find the cosine of pi over 2, okay? What's the cosine of pi over 2? Okay, I'm going to go up to this pi over 2 axis right here, and I'm just going to copy down that x-coordinate. The cosine of pi over 2 is 0, okay? 0. So the secant then, right, is going to be 1 divided by 0, which is undefined. So the answer to that one was undefined, okay? Cosecant of 120 degrees. Let's move on to number 5. So I'll erase. I actually don't have to erase anything. I don't have to draw a bearing. Okay. So the what was it? Cosecant of 120 degrees. You have to remember, guys. You must remember that the cosecant is just 1 over the sine. So I'm going to start by finding the sine of 120 degrees first. Okay. So 120. It's greater than 0. So I got to keep rotating to find his bearing. Okay. So let me. I'm going to draw the bearing for a sine of 120 degrees, okay? Start on the positive x-axis to the right. I start going up, okay? 120 degrees is greater than 0. It's also greater than 90 degrees, so I gotta keep going. And then it's also, what was it, 120? It's not greater than 180, so it's going to be somewhere in this second quadrant here. It doesn't matter where you put the bearing, just as long as it's in that second quadrant, okay? All right, because that 120 degree angle that they gave you is in the second quadrant, you're going to subtract it from, you're going to do subtraction with the numbers that are to the left of the axes here. So you want to do 120 degrees minus 180 degrees. And again, just take the absolute value and you'll get the sign, the correct SIGN every time. Okay, so 60 degrees. This is my reference angle. Okay. All right. I want the sine of that. Okay. So I'm going to take the sine of 60 degrees and write it down. Okay. Come up to my special right triangles. I have 60 degrees right here. Okay. The opposite side, sine SOHCAHTOA. Sine is opposite over hypotenuse. The side opposite 60 degrees has length root 3. The hypotenuse of this triangle has length 2. Okay. So our sine is going to be the square root of 3 divided by 2. Okay. Cool. And then again, we just got to make sure, okay? We just got to make sure, okay? I'm in the S quadrant. That means the sine of any angle whose bearing is in the second quadrant is going to be positive, okay? So sine of 120 degrees is going to be positive, okay? Then my answer I'm just going to have to take this guy, flip him over, okay? So 2 over root 3, then rationalize. There you go. Okay. All right, number 6, tangent of theta. Again, I highlighted that one. That's a special problem. If they give you one of these 8 angles here, in other words, if they give you an angle that's written on one of the axes, you just go to the corresponding point here on the unit circle, okay? So they gave me tangent of pi. I'm going to go to the nearest point on the unit circle, okay? Tangent is the y-coordinate, okay? So my tangent of pi is my y-coordinate here, okay? 0 divided by the x-coordinate, negative 1. 0 divided by negative 1 is 0. So those should be gimmies. All right, we didn't do great this time, and I don't think I did the best job teaching the quadrantial angles. Okay, Oh, okay, well. So 0 degrees is my answer. Sorry, guys. 0 degrees or 0 radians is my answer. Just 0, okay? All right, let's erase some of this. Okay. You do have to memorize this. I will say you do have to memorize that. Okay, so I'll erase all this. Get rid of all that. No, what the heck? Okay. Secant of 7 pi over 6, okay? You have to remember that secant is 1 over the cosine of an angle, okay? So we're going to start by finding the cosine of 7 pi over 6. Let's come down here. All right. Okay, you guys are really struggling with this, and that's okay, okay? 7 pi over 6, okay? So to draw that bearing, I'm going to think of pi over 2 as 3 pi over 6, okay? I'm going to try to, on all my axes, on all the radian angles on my axes, I'm going to try to get these to have a common denominator with 7 pi over 6. So I'm going to think of pi as 6 pi over 6, okay? I'm going to think of this as 9 pi over 6, okay? And you can ignore the pi's, okay? So when we're trying to find out where 7 pi over 6 is, okay, first off, just ignore the pi here, okay? Okay? And know that 7/6 is greater than 6 over 6, but less than 9 over 6, okay? Right? Because 6 is less than 7, which is less than 9. And then if we divide everything by 6, it still stays in the same place, okay? All right? So that means my 7 pi over 6 angle is going to be less than 9 pi over 6, but greater than 6 pi over 6, okay? All right, so then going back, that means that 1 pi is less than 7 pi over 6, which is less than 3 pi over 2, okay? So let's draw that bearing, okay? So I start here on the positive x-axis. I go counterclockwise, okay? My 7 pi over 6 is greater than pi over 2, so I got to keep going. It's greater than pi, so I got to keep going, but it's less than 3 pi over 2. So it's going to be somewhere here in the third quadrant, okay? Somewhere here in the third quadrant is my 7 pi over 6, okay? Since we're on the left side of the axis, I'm going to subtract it with this radian angle on the left. So I'm going to do 7 pi over 6 minus pi, and I'm going to do the absolute value of that, okay? So remember here, guys, we're having trouble subtracting these fractions, and that's okay. Just go ahead. You need to get a common denominator. So pi is the same thing as pi over 1. For both of these to have the same denominator, okay, I need to multiply the top and bottom of this fraction by 6. So this becomes 7 pi over 6 minus 6 pi over 6, okay? Now that these two fractions have the same denominator, I can subtract straight across the top. So my answer is just going to be, and it's an absolute value, so it'll be positive. It's going to be over 6. I keep that common denominator, and then I just subtract the numerator. 7 pi minus 6 pi is 1 pi, or just pi over 6, okay? One thing I want to note here, when you're working with pi and you're like doing subtraction in addition with it, you just treat pi like a variable. So like 7x minus 6x would be x, okay? 7 pi minus 6 pi equals pi, okay? That's why I have a 1 pi up here, okay? No, excuse me. So this number I just got from subtracting, that's my reference angle, okay? So I come up to my Special right triangles, again, I'm trying to find the cosine. Okay, so I'm going to find the cosine of pi over 6. So I have my pi over 6 angle here. The adjacent side has length square root of 3. The hypotenuse has length 2. So adjacent over hypotenuse is going to be the square root of 3 divided by 2. Okay, let's make sure then that we get the SIGN, the positive or negative, right. Okay, the angle, the bearing's in the third quadrant. It's in the T quadrant. That means only the tangent of that angle will be positive. The cosine and sine will be negative. So I just have to slap a negative sign on here real quick, okay? And then again, I actually want the secant, so I'm just going to take this number I came up with and flip it around, okay? So this is my answer. Just make sure you rationalize it or you will get partial credit taken off. There you go. Okay, sine of 270 degrees again, okay? The angle they gave me, 270 degrees, that's on one of my axes here, okay? It's on this, let me get rid of all this crap, sorry. All right, so that angle they gave me, 270 degrees, that's on, right? That's one of my axis labels down here, okay? So when that happens, okay, I just got to look at this corresponding point on the unit circle right here, okay? And I'm going to look at the coordinates, 0 and -1, okay? So I want what? The sine of that? Okay. Well, the sine of that angle is going to be the y coordinate. The sine of this 270 degrees down here is going to be the y coordinate of that corresponding point on the unit circle here, so -1. So the sine of 270 degrees equals -1. That's it. That's the answer. Cool. All right. Cotangent of 7 pi over 4. Cotangent of 7 pi over 4. Okay. So this is what we've really been struggling with. Okay. So we're going to draw the bearing for 7 pi over 4 on here. Okay. So I'm going to look at all my angles on my axes. Okay. And I'm going to write them as over 4. So the pi over 2 is the same as 2 pi over 4. Pi is the same thing as 4 pi over 4. And 3 pi over 2 is the same thing as 6 pi over 4. Okay. They want what? 7 pi over 4. Okay. So let's think about this. Let's just ignore all the pi's here. So let's just think of it as 7/4. Instead of 7 pi over 4, I'm going to think of 7/4. Okay. 7/4, right? My angle here is going to be in the fourth quadrant. Okay. I guess 2 pi is the same thing as 8 pi over 4. 2 pi is the same as 8 pi over 4 when I get that to have a common denominator of 4. So 7/4 is less than 8/4, but it's greater than 6/4, okay? All right, because 6 is less than 7, which is less than 8, and then if we just divide it all by 4, it's, okay, nothing changes, okay? So then 6 pi over 4 is less than 7 pi over 4. Okay, when we multiply everything by pi, it doesn't change, okay? All right, and then we can simplify these two fractions on the left and right. Okay, so 7 pi over 4 is between 3 pi over 2 and 2 pi. Okay, so if I draw that angle's bearing in, okay, it's greater than 0, it's greater than pi over 2, it's greater than pi, so I got to keep going, it's greater than 3 pi over 2, and it's less than 2 pi. So it's just going to be somewhere in this fourth quadrant here. Anywhere, I don't care, okay? 7 pi over 4 is what I'm really interested in, okay? All right. All right. Since my bearing is on the right side of the axis, I'm going to subtract it from these numbers here, okay? So I'm going to do 2 pi minus 7 pi over 4 and take that absolute value. That's going to give me my reference angle again, okay? 2 pi is the same as 2 pi over 1. Let's get common denominators. I'm going to multiply the top and bottom of this fraction by 4. So that'll give me 8 pi over 4 minus 7 pi over 4. Okay. And then my answer will be positive because it's an absolute value. And it'll be over 4 because that's my common denominator. 8 pi minus 7 pi, think of it just like 8x minus 7x, okay? So 8 pi minus 7 pi is going to be pi over 4. So this is my reference angle right here. So I'm going to come up here. I'm looking for cotangent, okay? Cotangent is going to be 1 over the tangent. So I want to come down here and find the tangent of pi over 4, okay? Here's pi over 4 right here in my special right triangles. The opposite leg has length 1. The adjacent leg has length 1, okay? Tangent, SOHCAHTOA. Tangent is opposite over adjacent. So my tangent of pi over 4, okay, so it's going to be the same as 7 pi over 4. My tangent of pi over 4 is going to be 1 over 1, or just 1, okay? And then I'm in the fourth quadrant here. That's labeled C. So only the cosine of angles in the fourth quadrant, angles whose bearings in the fourth quadrant, should be positive. So the tangent right here, I just got to make sure I slap a negative on it, okay? And then again, my answer is going to be 1 over that negative 1, or just negative 1, okay? So that's it. Cosine of 225 degrees, okay? Well, I think we're doing a lot better with degrees, right? I'll come down here. I'll erase all this. Okay. Get rid of all this. Okay, so we want the cosine of 225 degrees. So let's draw that bearing on here. Again, I think we're a lot better at doing this in degrees. Okay, so I start on the positive x-axis. I start drawing my angle up counterclockwise. Okay, my angle is greater than 90 degrees, so I'm going to keep going. My angle is greater than 180 degrees, so I'm going to keep going. It's actually less than 270 degrees, so I'm going to stop here in the third quadrant, right? They wanted 225. Cool. Okay, so there's my bearing for 225 degrees right here. All right. Since my bearing's on the left side, it's on the blue side, on the left side of the coordinate axes, I'm going to subtract it from these numbers right here. And again, you don't have to worry about the order. Just take the absolute value of that subtraction. Okay, that's going to give you positive 45 degrees. So this is my reference angle. Okay, I'm going to come up here. I'm going to look for the cosine of that 45 degree angle. Okay, so here's my 45 degree angles and my special right triangles. The adjacent side here has a length of 1. The hypotenuse has a length of the square root of 2. Okay, SOHCAHTOA, cosine is adjacent over hypotenuse. So the cosine is going to be 1 over root 2. Okay, but again, make sure you get the SIGN, whether it's positive or negative, right? Okay, my bearing here is in the third quadrant, the T quadrant. So only the tangent, and I guess cotangent, of 225 degrees are going to be positive. So my cosine should be negative. And then again, make sure you rationalize your answers. Okay. So there you have it. Okay, there you have it. That's all the answers to this quiz. Okay. Sorry, this video was kind of long. I just wanted to make sure I gave a really detailed method of how to do these problems. One thing I do want to say is on the test, if they give you if they ask you for the sine of an angle that's like greater than 360 degrees, or like the sine of an angle that's like negative, okay, what we're going to do is I'm just going to have you guys either add or subtract 360 degrees. Okay, so here we would subtract 360 degrees. We'd be looking for the sine of 40 degrees, okay? Okay, this is going to be the same. We'd add 360 degrees. This is going to be the same as finding the sine of 300 degrees, okay? let's just keep our degrees, our angles between 0 and 360, or if they give it to us in radians, so like sine of 4 pi, okay? Let's go ahead and subtract 2 pi from that. 4 pi minus 2 pi, that's going to be the same as the sine of 2 pi. If they ask you for the sine or cosine or tangent, okay, I'm just using sine as an example. If they ask you for the sine of like negative pi over 4, right? Let's just add 2 pi to that, okay? So that's going to be the same as the sine of 2 pi plus negative pi over 4. Or just 2 pi minus pi over 4, or 8 pi over 4 minus pi over 4, I guess 1 pi over 4, or 7 pi over 4. So that's going to be the same as the sine of 7 pi over 4. Okay, guys, please watch this video. I probably should have said that at the beginning, but let me know if you have any questions, okay? I'm really eager, really itching to do a review session with you guys. You guys take